Good morning. Happy Tuesday. Hope you enjoyed the snow day and the extra day off for the weekend. For day 110 today, we're going to continue to focus on transformation. Specifically, we're going to be looking at the translation and the reflection. And our focus is really going to be, as we're working with these rigid transformations, how does it change the coordinates of different points on our shape or different points on a graph? So jumping into the work quickly, already you and your partner should have worked through part A and part B. Part A tells you that on this graph, triangle ABC was going to be translated down by 7 units and then right by 5 units, and it would make triangle XYZ a purple triangle that's not shown on the graph today. You were asked to identify the coordinates for point B. That should have been straightforward. We know the X value left and right position for point B is -3, and we know the Y value, the up and down position for point B, is +4. If you were asked to find the coordinates for point Y, that was going to be from the image after we translate ABC down by 7 and right by 5, then at point XYZ, or that triangle, is made. So you could have gone and worked with this graph, recreated it, drawn out where the purple triangle would be. But I know if triangle B was going to be moved down by 7 units, that would affect the Y. 4 minus by 7 is going to be at -3. And for the X value, it's going to move right by 5. That increases the X value by 5. So -3 plus 5 would be +2. Again, if you had drawn this out, or if you had dragged this down, created a copy down by 7 and right by 5, you would see that point Y is at 2 and -3. It's now sitting here. But again, you could have done that more quickly. Part 3, it says, will triangle ABC be congruent to XYZ? Congruent, you have to know that means same size and shape. And of course, all we did was drag or translate here. So if I were talking about the proof for why they would be congruent, all we did was to translate. Then the trickiest one, part 4, said, what is the length for X to Z, line segment X to Z? I know that's going to be the same. X to Z is the same as A to C. You see X and Z are corresponding to A and C. And if I look on my graph, A to C is 3 units long. So the length for A to C was 3 units long. The same thing for the length of X to Z. It's going to be 3 units long. Moving very quickly into part B, and I'm sorry to be running out of time. For part B, they asked us to identify the coordinates for point P. And again, for point R. And point R, ultimately, the coordinates are going to be -4 for X, +1 for Y. We know that PQR is going to get reflected across this Y-axis, flipped over there. So the X value is going to change from -4 to the opposite side of +4. But the Y value is not going to change. It's going to stay at a +1. So if R is going to become point F, this goes from -4 and 1 to +4 and 1. You should know after the reflection, if our reflection line is the Y-axis, PQR is going to flip over into quadrant 1. That was all rushed. I'm sorry. Feel free to grab me if you have any questions today as you keep working. Good luck the rest of the way.